Hello grade 6, this is a video on how to do your evaluation. There's two parts to the evaluation. There's the evaluating of the method, that's this first lesson, lesson 10. And then there's also the evaluation of the hypothesis, that's next lesson, lesson 11. Linked to those two, you're gonna evaluate, which means you're gonna say the good things and the bad things and come to a bit of a conclusion. Obviously, those bad things are things that didn't go so well for your experiment. You can talk about how you could improve them. So the last video is going to be on errors and improvement. So that's looking at things that go wrong and how you're going to correct it. So let's look at today's lesson. I'm going to try and take my time today. Here, as always, is the suggestions of what you need to do. And then I've added in, because all of them start with the word discuss, I've looked up what the MYP definition of discuss is, and it says to offer a considered and balanced review. So balanced means we're going to look at both sides of things, whether it went well and what things didn't go so well. Offer a range of arguments, so not just look at one thing, but look at a range of things. Factors and predictions. Well, obviously, the hypothesis bit is going to be for the next bit when you evaluate your hypothesis. But you're kind of going to hypothesize like suggestions. You're like, well, my results weren't so close together. I think that it could be better if. And you're going to try and come up with a little conclusion at the end of it. And it should be presented clearly and supported by evidence. So you can't really say things like, I feel my results were good. No, you've got to tell me whether they were or not and why you think that or why you know that. And again, as always, here you can see like what's needed to get up to an 8 out of 8. If you simply state things, if you just say this variable was good, then that's only going to get you a 1, 2, or a 3, 4. Annoyingly, they're the same thing. Outline means to state something and then sort of say a little bit more. Discuss means to give both sides of it and then sort of come to a conclusion. That's the plan. And then again, as always, we have space for you to do this here. You'll notice that each of these bullet points that you can tick, when you've done the first one, you can tick it off. Each of them is a section in the table, yeah? So the first one, discuss how easy was it to keep all my planned controlled variables constant. That is box number 1, controlled variables. So you're going to answer that in there. Let me just get rid of some of my highlighting. And then last thing is, obviously, if you use any websites, you probably won't now. You probably won't use any websites. You might do for the hypothesis one. You might use some websites, so you'd have to cite those websites. But for this one, I would be surprised if you use any. But you can look stuff up, and there are people that have done similar studies, and they have commented on their thing. So you can look that up, and you can use their comments and their suggestions, and you can compare yours to them. If you do that, you have to cite it and say what website that was that you got it from or what book you were using. But yeah, again, probably not going to happen. What I'm just going to do now is I'm just going to add some space in my boxes here so that I can write in them. This is the fun part. You have to watch me make some spaces. Ooh. What's going on? Why have it? I've broken it. How do you undo that now? I might have to type. Return. There we go. Okay. Okay. So first bullet point, discuss how easy it was to keep all of my variables the same. How do I get rid of... Oh, you click on there, don't you? Yeah. So discuss how easy it was to keep all my plan control variables the same. So go back to your plan and see what your control variables were. You probably had control variables like the mass or the weight of the wooden block thing. Yeah? So, how easy was it to keep that the same? You probably used the same block, which didn't change throughout. And what other control variables did you have? Maybe the length of your string was a control variable when you made your parachute. So talk about whether that was easy or hard to keep the same. Once you started changing the parachute, I guess that started to get quite tricky. Dropping it from the same height, was that easy or hard? We were dropping it off the balcony, which was good, but were we always dropping it from exactly the same height, or did you change the person? If you changed the person, you probably had slight variations. So whilst you said it was 3 meters, it might have been slightly more or slightly less. So that's what I want you to do in control variables. Go through all of them and make a comment on whether it was easy, hard, was it perfect, which mass of the wooden block, it was probably perfect. It probably was exactly the same every time. But drop height probably varied slightly. How much do you think it varied? Make a suggestion. Do you think it varied by like half a meter? Then you discuss the reliability of your results. To be reliable means that you can do the same thing over and over again, or you always do the same thing. So look at your results. You did 3 repeats for each drop, for each parachute size. So on the large parachute, was it all the same time, or was there slight changes in the time? You decide. I'd be impressed if they were all exactly the same. So were there slight changes? And was that acceptable? Do you think that those changes were okay? Could you still... The question here at the very end, so you want to make a comment on like the data and how they're similar but not the same. Yeah? And then tell me if that's acceptable or not. Yeah? It would be acceptable if you still managed to see a pattern in your results. And if there were any anomalies. So an anomaly is where you get, let's say you got 3.10 as one timing, 3.12, and then you got 7.45, right? Clearly, this one is an anomaly. It's a mistake, and so you're probably just going to ignore it when you did your calculations. I don't remember seeing any anomalies, but there might have been. If you didn't have any anomalies, then that's a good thing. One of the comments on reliability of data is that there were no anomalies. Yeah? And then acceptable, you want to make a decision as to whether you could see a pattern or not in your results. Yeah? If you did it, you may have done an R squared on your graph. I think I mentioned it in the video, but I might not have done. An R squared is a comment on whether it's data that's really close to the line, or whether you get the line of best fit and the data is like all over the place. Yeah? So this would be a good R squared. The best R squared is 1.0. The worst is 0.0. 0.5 is good or fine. Anything above 0.9 is good or very good. Yeah? You might have got a 0.98. That's excellent. Yeah? That shows that the data is very reliable. Okay, remember before, we talked about the idea that you have to provide evidence for what you say. Well, your R squared is evidence. Your anomalies are evidence. Yeah? Equipment used. Was the equipment used good or not? You essentially used a stop clock that was on your phone. That's probably fine. And you can actually have a test of your reaction time if you do a website. And that's the only thing wrong with your stop clock, is that you have a human reaction time. It's probably only about 0.2. And if you got numbers like 3.5 seconds and your reaction time is 0.2, that's quite small compared to time. If you were timing something that lasted 0.1 seconds and you have a reaction time of 0.2, your numbers are going to be very bad. If you're timing something that lasts 3 hours and you have a reaction time of 0.2 seconds, then the reaction time has no impact whatsoever. Yeah? So you need to comment on that. Also, equipment used. You measured the size of the parachute. You probably used a meter stick. Do you think that was a very good method? Did you measure all 4 sides? Or did you just measure 2? Probably just did 2. That's what I suggested. Which means you're just assuming that the other side is done. So, that's not too bad. And then also equipment used, I measured the height. Okay, and my method probably wasn't very good. I measured it to be 3 meters, the height of the building, but I just hung a piece of string over till it touched the floor and trapped it in my fingers and pulled it back up again. And then I just told you that that was the railing. That's not necessarily a very good measurement. So you can comment on the equipment. The piece of string used to measure the height was not very good. So that's these done, isn't it? Did we do a control? A control means this is more a biology thing. A control would be where you drop if you're growing plants and you're changing the amount of water you give them, you just let a plant grow naturally and you can compare it then. So actually we don't have a control, so you can delete that from ours. Doesn't happen in physics very often, having controls. Now I want you to go through your method and I want you to look at what things were good and bad. The way that you timed it was probably very good. And maybe you had a method of communicating to each other about when to drop and when to start the timer. Yeah? And you just, in strengths and weaknesses, you just look at the good things and the not so good things. So timing was probably a good thing. Maybe your communication to start and stop the timer could be improved. So comment on whether it was good or not and how might you improve it. You're going to remember these things because these things are all going to come up in lesson 12 again. Yeah? So make sure you've written them down. Hopefully you'd write them down in this. Okay, now, precision. Precision is talking about the scale. So your timing was probably 3.10 seconds, right? That is pretty precise, the 0.10, yeah? The distance that I measured was 3 meters. That's not very precise, is it? 3 meters means it was anywhere between 2.5 to 3.5 meters. They round, or 3.4, they round to 3 meters. So precision is not very good here. It's a meter out. It could be a meter out of 3 meters. That's 30%. That's not very good, is it? So we could comment on the precision of that. This is probably quite good, and you can comment that that was a high precision. Yeah, but this is a low precision. And then your method for measuring the area of the parachute, we worked out the area using a square, did one side multiplied by the other side. But what if it wasn't quite a perfect square when you made your parachute? Then A times B is not going to be very good. So you can comment on the precision of your measurements there. Then finally, so we've got some more to tick off, haven't we? We're not doing that. Strengths and weaknesses we talked about. The last one is discuss if the variables that I chose were best for answering the question. Okay, your question was probably something like, or hopefully something like, how does the size of the parachute affect the time it takes to fall 3 meters? And you changed the size of the parachute and you tested the time. So essentially, you chose the right variables. But some people said things like, I'll find the speed of the parachute rather than the time. And then you measured time, so you don't know speed. So perhaps your one wasn't a great choice of variables. And then you can also comment on like the sizes we chose. Even if you change the size and measured the time, that's good. But our sizes, they only went up to like 1 meter squared, didn't they? That's not a true representation of the real world. So I want you to comment on whether the values you chose, a choice of variables, were good or not. Yeah?